Archive started.
All right, welcome to Women in Science and Engineering. The Women in Science and Engineering program at VCC is committed to the recruitment, retention, and advancement of underrepresented groups pursuing careers in science and engineering. It is open to all students. We include seminar series with guest experts like we have today, workshops on careers, resume building, graduate schools, networking for future schools and employment, local excursions, career mentoring, and undergraduate research. Today we have our guest speaker, Jessica Bean from Harris. She is a systems engineer. Our next speaker coming up is February 19th from Health First on health administration. March 19th is on the genetics of lupus, one of our own instructors from the Palm Bay campus. And April 16th, we have a vision and perception science, including her specialty is in aviation, on April 16th. These are our speakers for this semester. Without further ado, let me introduce Jessica Bean. All right.
All right, so I'm Jessica Bean. I'm a systems engineer at Harris, and I'm really excited to be here and talk to you about systems engineering, engineering in general, and I'll tell you a little bit about when I was a student. But first, a little bit about me. I was actually born in Melbourne. I went to Palm Bay High School. I went to Florida Institute of Technology. I must really love Melbourne because I've been here my whole life. I never actually left, and I'm working here now. I've worked in engineering for over 10 years. And I spent the last 5 years as the IEEE Melbourne Section Chair, and that is the professional society for electrical electronics engineers in this area. So tonight, or this afternoon, we're going to talk about just kind of my story, how I picked engineering, what do engineers do, those kind of things, my career, and we're going to talk about electrical engineering, which is my undergraduate degree. We're going to talk about systems engineering, what I'm doing right now. Just my general experience as a student and kind of the process I went through being a student, figuring out what engineers do. I'm going to talk to you about some things I wish someone would have told me as a student. And I'm also going to speak a little bit about work-life balance, which is a very common women's issue in most professional careers. So how did I pick engineering? You go through your life and you grow up and you go, people say, well, what do you want to do when you grow up? And I had no idea, and I never did. In my whole junior high school, people were, oh, what do you want to do when you grow up? I had no idea. And so when I got to high school, it finally occurred to me, maybe I should have an answer for this question. And so I decided that the thing I really liked to do was play music. And I was an oboist. I played in the band forever. I was actually very good. I was one of the best in the state. And so I was going to be a music major. And about my senior year, it occurred to me that my oboe teacher often didn't have a phone, and that this may not be the best way to make a living. And so I've got this picture of this guy, and he's got a little sign, and it actually says, starving musician and dog on anything will help. So I did not want to be that guy, so I decided I needed a new plan. So why did I become an engineer? There's a bunch of different reasons. Mine is mostly return on investment. Engineers need to do math. I knew that much, and I like doing math. I was good at math. Big thing for me was time. Engineering, you can come out and be an engineer for a bachelor's degree, 4 or 5 year degree, versus if you want to be a lawyer, that's 7 years. If you want to be a doctor, that's 11 years. Another thing big for engineering is salary. This is the national average for starting salary for a graduate with a bachelor's degree in electrical engineering right now is $61,000 a year. So I thought, this is straight out of school, little no experience, and I can make a really decent paycheck in engineering. Another reason is demand. Engineering is always in demand, even in a down market when they're not hiring a lot of engineering. It's one of the first things to pick up simply because companies need to innovate, and to innovate, you need engineers. So 4 big reasons. And then the other one was I don't like being bored. I didn't want a job where you had to do the same thing over and over and over. I wanted to do cool things and interesting things, and I knew engineers got to do cool things. So this is my big reason for being an engineer. If you know, none of this has anything to do with technology or me even knowing much about what engineers did. And so this is a very flippant choice for me. And my dad was an engineer. He didn't really tell me a whole lot about what they did. He couldn't really put it into words I could understand at the time. I was good at math, and so I figured, how bad can engineering be? And this is my very flippant choice. And then I went, well, what kind of engineer am I going to be? You've got to pick a major. And so I actually decided my particular major based on a career fair flyer These are when you're in school and they have these career fairs, they bring in all these companies and they say all the degrees that they're looking to hire. And the one degree that was on every single person's list was electrical engineering. And I thought, well, that sounds like a good plan for me. It seems to be, it's always in demand. And so that was my degree, electrical engineering. That's what everybody seems to want to hire. That's a good plan. And it's actually not a bad way to choose a career, but looking at demand and what you think is going to be for your industry going forward and how many companies want to hire that major or employ people in that field. So still at this point, no clue what engineers actually did. So what do engineers do? I spent about a year in school, no idea what engineers did, and I figured it had to be something kind of like this little video I have.
Serious research which marks completely other focus. All right, that's what we're going to work. But I didn't ask them how to do it. All right, yes, good.
All right. I wish it was that cool with the soundtrack, but it's not. So having done all that math at school, that's what I figured it might be like. Not exactly that way. So I'm going to talk to you a little bit about my career path. My first engineering job was an internship. I worked for Northrop Grumman, and I actually worked for them for a couple of years. And then I graduated with my bachelor's degree in electrical engineering in 2003, and then I'm an electrical engineer. Let's go back. So what do engineers really do? Engineering is the practical application of science. And engineers work on teams to solve various problems. And we have this general cycle that we go through every time. When we have a problem, there's a design activity. We figure out, well, what are we going to do to solve this problem? There's a development activity where we actually develop something to solve the problem. And then there's some kind of test activity where we make sure that what we've made actually solves the problem. And so this is a little picture with this kind of similar path, a simplified version of it, but we do the same kind of activity over and over for different problems. So an electrical engineering is the very broad engineering discipline that includes everything from power, control, electronics, all the way down to software, embedded software. So electrical engineers are really viewed to be able to do huge amounts of engineering. That's why it's always in demand, because you can be a software engineer as an electrical engineer. You can be a power engineer, you can be a controls engineer, you can do robotics and electrical, and you can do what I did, which is telecommunications, RF communications, antennas a little bit. So I've got all kind of pictures up there of things electrical engineers work on. We have phones and power and iPads, all of these things with silicon, semiconductors, all kinds of stuff electrical engineers can do. And I actually interviewed once for a job, and it was mostly a software job, and I was a student at the time, and I said, well, don't you want a software engineer? And the guy says to me, he says, well, I can teach an electrical engineer how to program. I cannot teach a software engineer electrical engineering. It's kind of a big moment for me. So that's something to consider if you're interested in that software engineering field, that you may want to go an electrical engineering route simply for that reason, because you can get that software education, but not quite the same as a computer science education. So it is definitely something to consider. So for me, I started working as an electrical engineer. My title was an RF communications engineer. I worked for Northrop Grumman for 4 years, and I did satellite communications, HF, UHF, VHF, radios, filters, and I actually had a job where I did a lot of math. I was an analyst, and what I did was called cosine analysis, and this is the analysis of self-interference when you have lots of radios co-located close together in frequency and in physical space. You can see some of these pictures on these planes that have these huge little prongy things. These are all antennas, and those are very carefully placed, and there's filters designed so that when someone is on that plane and wants to go and use a radio to communicate, that they can just turn that sucker on and it works immediately. There's a lot of engineering that goes to do that. So I've got a few pictures from things I've worked on. This is a joint stars airplane, it's a radar plane, lots and lots of comm links on it. This right here is actually a model of an airplane with antennas. This is the front some of the radiation patterns, different antennas there. I've got some signals and some noise and things like that. Those are things electrical engineers are familiar with and can work in. So about a little bit into my career, I had this moment where I had too much free time. It was my first year, really, where I was done with school, and I started working, and I would go to work and do my work and come home, and I had nothing else to do. There wasn't any projects hanging over my head. There wasn't any tests I had to work on. There wasn't any research papers I had to write. It was a really strange feeling. I decided I had too much free time, and it's very common for engineers to go back and get a master's degree if they don't get one straight through. And so I figured if I have all this free time, I better get a master's degree before I get used to that free time, and then I'll never want to get a master's degree. So I got a master's degree while working. I actually started in 2004. I finished in 2007, and I got it in systems engineering. For a couple of reasons. The main reason that I picked systems engineering is because it was free. My company actually paid for me to go through this program. They paid for my tuition, they paid for my books, and they actually gave me a laptop to do this. So number one, it was free. That sounds good. Number two, I got a laptop. Also sounds good. And all I have to do is show up and do the work and get the degree. I'm on board with this. And number two, systems engineering, which we're going to talk about, is this interdisciplinary engineering field. It's broad, it's high level, it's a leadership engineering field, and that's kind of where I naturally said I'm a big picture thinker. So I thought, okay, well, maybe I'll get into that at a later point in my time. So system engineers know a little bit about a lot of things, and we focus on solving a complete problem versus a design discipline like an electrical engineer or a software engineer will focus on solving their specific discipline problem, this electrical engineering problem or software engineering problem. Systems engineers will focus on the whole picture. Systems engineering focuses on not only are you solving the problem, but what are you going to do for operations? Are you going to complete your project on cost and on schedule? What kind of performance, system level performance are you going to have when you put all these pieces together? How are we going to test it? How are we going to manufacture it? How are we going to train people to use it and support the product? And what are we going to do at the end when we're done with this product and get rid of it? How do we dispose of it? And also, system engineers tend to be responsible for the system's technical integrity. And what that means is that we're making something that is solving the problems the customer originally wanted. So we're going to show you this very classic cartoon in systems engineering. I've got a picture of it right here. This is a tree swing. And we have a customer who comes and I want a tree swing. And this is what they have in their head. This beautiful little tire with a rope. It's very nice with a tree. But what happens a lot on large discipline or large projects, you have multiple disciplines, you have multiple people coming in, and they all have their own little view of what they're going to do. And very often a customer doesn't always know how to explain what they want in their head. So we have he's thinking tire swing, but this is what he actually says. It's kind of a weird looking swing, right? And so different people have different views of it. So this is how the project leader understood it. Next one's how the analyst designed it, how the programmer wrote it. And the one at the end is how the business consultant described it. It's just like business development. I'm getting an easy chair here. It's amazing. And we have some more. We've got the next one here is how the project was documented. There's nothing. Nobody knows how it works. How operations installed it, how they were built to this roller coaster. It's a little ridiculous. How it was supported, and what the customer really wanted at the end of all that was a stupid tire with a rope on it that swings so they can swing on the tree. So system engineering prevents this problem and makes sure that we're all kind of cohesive and working in step together to build the tree swing that the customer really wanted. So I actually started in systems promptly after I finished my master's degree, and I went to go work for Harrison Systems Engineering. Done a lot of different things in systems engineering, lots of different technologies, applications, but somewhat revolving around my core discipline, which is why systems tends to be that leadership discipline. You have something you've worked in previous before that you know something about, and so you expand on that piece. So lots of different things, still a lot of satellite communications, a lot of power amps and filters and RF analysis, but also things like cellular communications and networking radios and all different kinds of stuff. So a lot of pictures here, and these pictures focus a lot more on system level pictures. You see, okay, well, I'm on a satellite, I'm at a ground station, I'm sending a signal to a satellite sends it back down to another ground station. There are large system pictures, and this one on the far end is systems engineering touching lots and lots of other engineering disciplines, because systems tends to be the glue for all of these other engineering functions and project functions. So as a student, though, I really didn't know how any of this stuff worked. And about midway through my degree, it occurred to me that I actually have to make brand new things that nobody has thought of before. And I thought, oh, man, I'm in trouble now. And I figured, okay, well, there's got to be something very special about engineers that allows them to just be able to create brand new things that nobody's ever thought of. So I got a little clip to show you about this.
I've been sitting here.
Here's what I thought.
Change the battery in the remote. The one on the left, the one on the left. Well, that's just stupid. Not really. I have the knack for technology. My mom says I always had.
I'm worried about little Gilbert. He's not like other kids.
What do you mean?
Yesterday, I left him alone for a minute, and he disassembled the TV, our clock, and the stereo.
That's perfectly normal. Kids take things apart.
Oh. The part that worries me is he used the components to build a ham radio set.
Oh, dear.
Is that bad?
Not only I want to run the EEG out, but the machine isn't working.
Oh, God.
It's worse than scary.
What is it?
I'm afraid your son has the knack.
The knack.
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical and other social entities.
Can he lead a normal life?
No. But be an engineer. Yeah, don't blame yourself.
Will he go away over time?
I'm afraid it doesn't. If an engineer loses the knack, the results can be devastating.
Thanks for filling in for our regular doctor on such short notice.
How does he know that?
All right. So that's the knack. So here's my secret. I didn't have the knack. I didn't tinker. I didn't take things apart. I wasn't this inventing kind of person. I did not have the knack. I just picked engineering because I was good at math. And I actually did not consider myself to be particularly good at science. I wasn't particularly bad at it, but I didn't feel like I was particularly good at it. So I really kind of randomly, flippantly picked engineering. And midway through my degree, I had no idea what engineers did. So what made it worse for me is having this feeling, okay, well, I don't have any new and amazing ideas to bring to the table. If I did, I would have been the iPad creator, and you would not see me here right now. And I was often the only girl in the class. Electrical is almost the final frontier of engineering. It's very rarely do you see a lot of women in the class. I was either the only one, or I was one of two or three. And so there's that subtle message that girls don't do engineering. It's there, and that doesn't help that situation because you're already intimidated. There's no other girls hanging around. But my situation, because I like to do everything the hard way, is I was pregnant my junior year, so I was committed. I needed to finish. I had to finish this degree so I could get a reasonable job and support myself. So I finished, and I committed to getting this electrical engineering degree. No idea what engineers do, don't have the knack, all that stuff. I got through it, I finished, and I was working, going to school, and had an infant daughter my entire senior year at school. So the right side of all this stuff, I'm in school, doing all these things, it's crazy. I actually was getting good grades. I was one of the top students in my class. I actually graduated second in my class, even though I had this baby. And by the summer after my sophomore year, I had an internship, and I kept it for the next 2 years, being able to start working in engineering as an intern. So these are the things I wish that someone would have told me. As an engineering student, you will learn fundamental math, fundamental science, and problem-solving skills, so that when you get your bachelor's degree in engineering, you officially know how to think. That's really all you know, is how to think. And it's okay. An engineering student, a new grad, practically useless to anybody, and it's really okay. We expect that. It's normal. So if you want to be an excellent student, you will have a strong foundation in what you're being taught to do, which is math, science, and problem solving. You'll do a good job in school. Number two, you will have a positive attitude. Nobody wants to work with the whiners and the complainers. Nobody likes that. You want to have a positive attitude. Number three, an enthusiastic interest in the technology that you will be working with or you are working in. Get excited about it. Learn some of the details. Read about some things in your industry. Read about whatever your degree is going. Even if you don't understand half the stuff you're reading, just try to read. The more you do it, the more you'll like it, I promise. And the other thing that an excellent student or a new grad will do is they will have worked on projects or have worked as a co-op student or an intern or something. So what you should do at this point, if you're going to be an engineering student, is seek to be employed as an intern or a co-op student as soon as possible. This normally happens after the sophomore year. It can happen in the junior year. It can happen early in the sophomore year. But right after your freshman year, start figuring it out. Start trying to get an internship. Start trying to sign up for a co-op. session, anything like that that you can do, because you learn through application. You can't always control if you're going to get an internship or you're going to get a co-op job or any of those things. You can't control it. But what you can control, even if you have a hard time getting a job, is you can do projects. And engineering students should do as many projects as you can. You're not going to get paid for it. Probably won't get credit for it for class. But projects do 3 big things for you. Number 1, it's great experience. You are going to have this experience where you're applying math and science. You're trying to build something. You're working as part of a team. You're solving team conflict problems. All of those things we do every day. It's not necessarily about a small little engineering student project, but about a bigger project. But all of those experiences you have will teach you all of those skills. Applying math and science, problem solving, teamwork, dealing with conflict. Number 2, doing a project gives you something to say in an interview. So even if you can't quite get an internship, if you're doing some projects and everything, when you go to talk to people in an interview, you have something to talk about. You can talk about what you did on your project. You can talk about your experience. You can talk about problems that you had and how you solved them. Those are great things, and they give you something to say. I actually interviewed once, and the people interviewing me mocked the person before me. They actually made fun of him because he had worked at Chili's, and here I had worked as an actual intern, and I'd done these projects and things like that. So people do pay attention to your work experience and your project experience. It is something. It gives you quite a bit to say. And number 3, doing projects give you a really good excuse for not having perfect grades doing these projects. So maybe you got some more B's and those kind of things. You weren't the 4.0 student, but you were very busy and you were applying what you learned. It's a great excuse for not having perfect grades. So you're going to learn this application of science and math to making new technology through your experience, through education, through doing projects, and through actually working. And it's okay if you don't come to the table and go, oh, I've got this amazing idea for something, if you're not thinking of yourself like that kind of person, because you learn that as part of the process. The longer that you work, the more projects that you do, and the more that you apply. So the last thing I want to talk to you about is work-life balance and how to keep work-life balance. The big issue in all professions, and particularly for women, it usually hits women. And the first thing that you need to know is ask for what you need, ask for what you want. If you want something and you don't ask, nobody knows you want it, so they don't know to give it to you. People don't read minds. And so this is applicable for everything: negotiating a salary, negotiating a raise, convincing your spouse to do the dishes, any of those things. If you need something or you want something, ask. That opens the door for you to get something you want. Number 2 is for work-life balance, carefully guard your free time. And you want to be ruthless about this. It is okay to say no to activities that you don't enjoy, that you're not getting something out of. And you need to be okay with saying no. Women very commonly have a hard time saying no. We have some guilt. We have a lot of societal pressure. Culturally, we're supposed to be these helpers. And we have some of this thought from 50 years ago when most women were stay-at-home moms. And it's just not the case now. So it needs to be okay for you to say no. So look at all of the extra things that you do and go, okay, am I really enjoying this? Do I really get value out of this? And ruthlessly do it every year or 2 just to make sure that you're not signed up to do tons and tons and tons of stuff, or you will not have a work-life balance. Number 3 is make sure that whomever your management is, that when you start working, that they know what you're working on. And one of the best ways for you to do that and to communicate what you're doing and how much work you're doing is to keep written status notes. So every week, every 2 weeks, you keep your own notes. What have I worked on this week? What have I completed this week? What have I done? And send that to whoever your group leader or your manager is, so they know, hey, such and such is doing all this great work. So I actually work a part-time schedule. I work 32 hours a week. I don't work 40 hours a week. And I spend a lot of time very carefully managing how much work I'm given. In engineering, it's very typical to get a lot of extra work, and they'll just give it to you, give it to you, give it to you. People work 50 hours for free, 60 hours for free, routinely. I don't do that. I get paid for the most part for most everything I do, and it's because I'm very careful to manage the scope that I have to do and what I'm supposed to be responsible for, and that my management knows, hey, I'm doing all of these tons and tons of things, and I'm doing them in 32 hours, so they're already getting a good deal. Don't give me anything extra. Last thing that is really, really important for work-life balance is pick a supportive spouse. This is like the number one thing. If you want to move ahead, if you want to do really well, you want to have a spouse that's flexible with you, so that you guys can change out. And sometimes you're picking up the kids, and sometimes he's picking up the kids. These kinds of real life issues happen all the time. And maybe one day you're doing the dishes, but maybe he's doing the dishes the next day because you have something you have to do. When you're having that busy life, having a spouse that's supportive of you and flexible is a huge, huge thing. So that's all I have. It's actually pretty brief. Do we have any questions or thoughts? Anybody want to share? think we're good. Oh, we got a question from Jeff. Is the engineering degree, is it 5 years? An engineering degree, it depends on the degree field. You can do it in 4 years. Some people do it in 5. Some programs are 5-year programs. There's a lot in engineering. It's a very heavy degree.